Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. This is the 7th video guys, which simply means I'm doing question number 7. It's 7 out of 11. Just know that the other videos are already uploaded guys. You can just click the link on the description below. It will direct you straight to the playlist whereby I'm answering all the 11 questions, and all those 11 questions are extracted from past exam question papers. Please do keep that in mind. And also the first playlist is for those who still want to learn fundamental principles in work energy and power. Yeah, there's a gradual step by step teaching over there. I do recommend it. And then another thing, please do share this video guys to your peers. A thing or two that I'll mention here might help them prepare for an upcoming test probably, or an upcoming exam, and also help them elevate their knowledge in work energy and power. Please do like, comment, and on the comment section guys, I'm expecting you to write down questions if you have them, and also alternative ways to get to the solution. Yeah, before I start guys, please do subscribe just to help us grow the channel. Okay, we are told that the diagram below shows a boy skateboarding on a ramp which is inclined at 20 degrees to the horizontal. A constant frictional force of 50 newtons acts on the skateboard as it moves from P to Q. Consider the boy and the skateboard as a single unit of mass 60 kilograms. Ignore the effects of F friction. Okay, first question, they want us to draw a free body diagram showing all the forces acting on the boy or on the boy's skateboard unit while moving the ramp from P to Q. Okay, the boy is in the universe, right? So he will experience a gravitational force, weight, all together, and then there'll always be a frictional force which opposes the motion of the boy, friction, and then there's normal force which is perpendicular to the surface. You will get your full 3 marks now. However guys, whenever you deal with inclined surface, I always prefer to draw my free body diagram using the components of gravitational force. Alright, together. I'll simply draw my free body diagram like this. Yes, there is frictional force. There is friction, and there is F normal. And then we have our components of gravity. We'll have the Fg parallel, the force of gravity which is parallel to the inclined surface, and the other component which is perpendicular to the inclined surface. All right, together. Remember that we calculate Fg parallel by just saying mg sine theta. Fg perpendicular is just mg cos of theta. The theta just represents the angle between the inclined surface and the horizontal. Are you together? So it's up to you guys. If you prefer drawing it like this, kudos. Like this, okay. Then now we are told that points P and Q on the ramp are 25 meters apart. The skateboarder passes point P at a speed of VI and passes point Q at a speed of 15 meters per second. They want us to, okay, they're telling us to ignore the rotational effect due to the wheels in the skateboard. Then 5.2, we are being asked to state the work energy theorem in words. It simply states that the net work done on an object is equals to its change in kinetic energy. Okay, and then 5.3, we are supposed to use energy principles to calculate speed VI excuse me, of the skateboard at position at point P. I can simply use my work energy theorem. It simply states that work net is equal to the change in kinetic energy. I'm being restricted here, guys, to use energy principles. I can only use work energy theorem. I cannot use work done by non-conservative forces because I don't know the height over here. Yes, I can calculate it because I have a right angle triangle, but don't want to complicate things. Let's just stick to work energy theorem. Work net is equals to change in kinetic energy. By definition, the work done by a force is equals to the product of the force in question and the distance traveled in the direction of the force. All right, together. Basically, what that means is just F net delta x cos of theta. This is equals to work net. All right, together, and then change in kinetic energy. It will be the kinetic energy at position Q minus the kinetic energy at position P rather, not R. Okay, how can we find F net? By definition, F net is sum of all the forces in one dimension. If I'm going to focus on the forces which are parallel to the direction of motion, I have Fg parallel and frictional force. Are you together? Fg parallel is in the direction of motion. So for me to find F net, I need to say Fg parallel plus a negative frictional force. Negative frictional force. Why is frictional force negative? Because it's opposing my motion. Mg parallel, I can get it by saying mg sine theta minus the frictional force. Mg sine theta, that's 60 multiplied by 9.8 sine 20 degrees minus 50 newtons for a frictional force. So I'll simply say 60 multiplied by 9.8 multiplied by sine of 20 degrees minus 50. This will give me 151.11 newtons. All right, together. So I do know that the value of my resultant force is just 151.11 newtons. Then for me to find the velocity, I just need to substitute my values. F net, I know that's 151.11, 151.11 multiplied by 25 cos of 0. All right, together. F net, guys, is in the direction of motion, so it's cos of 0. Okay, that's 1 over 2 multiplied by 60 multiplied by 15 squared. The speed of the boy in the skateboard combination at position Q is 15, right? Then I'm looking for the velocity at position P. That's what I'm looking for. So 151.11 multiplied by 25 cos of 0. This will give me 3077.25. And then on the other side, I'll have 1 over 2 multiplied by 60 multiplied by 15 squared. This will be 6750 minus 30 times VI squared. Okay, physics is done now, guys. Now you're doing maths. Whenever I take the negative 30 to the other side, it will become positive. Let me write with a different color. I'll have positive 30 multiplied by VI squared. And then on the left hand side, I'll have 6750 minus 3777.25. 0.25. This will give me a 2972.75. Whenever I divide both sides by 30, what do I get? I'll get VI to be equals to 99.0916667, and then square root on both sides. That's 9.954 meters per second. Just round off to 2 decimal places. Né? So the speed at position P, that's 9.95 meters per second altogether. And then I'm supposed to calculate the average power dissipated by a skateboard to overcome friction between points P and Q. Né? I can simply say P is equals to frictional force multiplied by the average velocity altogether. I'm given the frictional force as 50 newtons. Average velocity, it's just the initial velocity plus the final velocity all over 2. This will give me the average power to overcome friction. 50 multiplied by 9.95 plus 15 all over 2. This will give me 623.75 watts. That's how, guys, we deal with e-power. I just hope, guys, the video helped you out. Just stay tuned, guys, and wait for more videos. Thank you.